I'm Carmen Enz, engineer with On Semiconductor, and today we'll be evaluating the effects of capacitance from protection devices on high-speed signals. We'll be looking at especially USB 2, which runs now at 480 megahertz. We'll take a look at our setup now. We'll be using a signal generator. We have the Hewlett-Packard 8133A, and it's going to be feeding a USB 2 signal of 480 megahertz through the line into our board that will have the device under test, and that will go straight into the oscilloscope, from which we'll be looking at the I diagram. The high frequency board we'll be using for these tests is just simply an SMA connector on both sides with the part mounted in the middle, and this part will add different capacitance depending on which part we're using. First, we're going to demonstrate what it looks like without any capacitance on the board. So we're feeding a pure 480 megahertz signal straight into the oscilloscope with no part mounted on the board, meaning there's zero capacitance. On here we can see the I diagram created by this signal. An I diagram is produced by repetitively sampling a digital signal on an oscilloscope's vertical axis while triggering the horizontal sweep with the data rate. The resulting pattern looks like an I. The larger the I, the better the signal integrity. Acceptable signal qualities are defined by the use of a mask. You can see the mask on the screen, on the oscilloscope screen. The mask consists of a hexagon in the middle of an I and rectangles above and below the I. If the measured traces cross the mask boundaries, the signal quality is considered unacceptable. The first device we're going to test is the ESD 9X 5.0 device, and it has 65 picofarads of capacitance, so it's not intended for high-speed use, but we'll see what it looks like with an I diagram. The I diagram shows significant signal degradation. Rise and fall times show significant increases. The use of a high capacitance device introduced distortions and degradation to the high-speed data line. The signal traces cross the USB 2 mask, demonstrating that this protection device cannot be used in a USB 2 device. Now we'll be testing the ESD 9C device, and it has a lower capacitance of 6 picofarads. We can see that the I diagram has improved, but there is still noticeable degradation of the signal around the rise and fall times. Also, by the max and min voltage levels, it can be seen that the signal crosses the mask, which means that this would make it unacceptable for this data speed. The last part we're going to be evaluating today is the ESD 9L 5.0 device. This device was created specifically for high-speed data signals such as the USB 2 at 480 megahertz. It has a low capacitance of 0.5 picofarads. The ultra-low capacitance of the ESD9L device offers a good design option for semiconductor devices for USB 2 high-speed applications. The I diagram demonstrates the ESD9L has logic levels with no distortion to the rise and fall times, as we saw earlier with some of the other parts. This option leaves the designer with budget for other components that add capacitance to the line and also helps maintain the signal integrity of the USB line. I'm Carmen Enz, and thank you for your time in allowing me to explain to you the benefits of On Semiconductor's low capacitance ESD protection devices.